Hello, everyone. Today we're going to solve once again, the Leet code question, merge to sorted list. However, this time we're going to tackle it by using constant space. So we're going to change it up a little bit. I do have previous versions of this problem. I strongly welcome you to first watch the video where we use two vectors. So essentially we take two sorted lists, and we go ahead and merge them into one list. In the first example, I try to ease into it by using kind of a more straightforward data structure, which is just vectors. For the second video, I went ahead and performed this problem using actual nodes, linked lists instead of vectors. Except I performed a deep copy. So what that means is we had these two lists. So these are all like size 3 linked lists, size 3 as well. And what we did is we traversed both of the lists. And what we did is we created a copy of all of those nodes. And we created essentially 6 new nodes and chained them together in the correct sequence. So that's, as you can tell, that's space complexity of n, because we're however many elements or however many nodes we have, we're going ahead and copying all of those into a separate linked list. And that's really just to retain the original versions of the list. But what if instead you wanted to take this list, and what you would do is just have a dummy node here. So kind of don't mind the dummy node, but what we would do is you would point the dummy node to the first value. Then you would go ahead and erase its connection that it has in the list. We would go ahead and go to the next value that's in order. So this node points to this node, and we would erase its connection that it has. We would go ahead and point this node to the next node in ascending order, and we would erase its connection, the current node to the next node in increasing value, and we would erase its connection, this node to this node. It has no connection. It's technically just pointing to null. So it does have a connection. It's just you don't see it. And then lastly, we would go ahead and point this node to the last node, and this is already pointing to null footer, so we don't have to worry about that. But just know we're going to merge these two together. So we're going to use constant space. So whatever space is out there, so whatever number of nodes exist, we're going to chain them together. That's really the approach here. Once again, I strongly recommend, if you haven't done so already, going through the playlist called Leet Code Solutions Easy. These are all going to be easy problems, within the easy categorization within Leet Code. And you're going to look up this problem right here, Leet code merging two lists using vectors. So go ahead and check out that video. That'll teach you all of the programming logic you need to use it with vectors, which is a simpler data structure. Then my previous video was merging two sorted lists, but this time we are using linked lists and we're performing our deep copy. So that one's also a really good video. In there, I also kind of explained what nodes are, what singly linked lists are. And so it's a really good overview, especially if you're not familiar with nodes and linked lists and a little bit of pointers. I don't really go too much into depth with some pointers, but just it's a really, really good overview. So I'd strongly recommend watching this one. And then for the current video, we're going to go ahead and take that constant space approach. So it's pretty fun. In order to do so, let's go ahead and remind ourselves what it's asking. So we're given the heads of two sorted linked lists. So list 1, list 2. So the head for list 1 is going to be pointing to this first node. The head for list 2 is going to be pointing to this node. So here we have our two lists, and we eventually wanted to get it to combine to merge into actually one list. So we combine these two into this big list. We don't ever create new nodes. And notice they're going to be in ascending order as well. The logic for that, pretty straightforward, but we're going to go through it in our pseudocode example. So you're welcome to use the timestamps below to go ahead and skip to those locations if you want to go to either the pseudocode or the actual coding implementation. I'll have those up in a moment. And now we can imagine for our test cases, so if I have the example 1, 2, 4 and 1, 3, 4, we could see that in sorted order, once they're merged, it's going to give us 1, 1, 2, 3, 4, 4. So that's going to be the order of our nodes and the way they're chained together. If I have two empty lists, they combine to nothing, right? If I have one empty list and one with one single node, then only that single node is provided into the final outcome. What's interesting too is if, let's say I had let's say one empty and then one that still had values in it, like let's say 1, 2, 3. Well, essentially all I would need to do is I would just need to put this list or define this list as my output, just because I don't need to perform any addition. So what's really easy about this problem is once you get to a point where you're down to one list, it's a one-liner. That's all it is. It's only kind of a little bit tougher when you have two lists. That's where you have to perform multiple steps. But if you only have one list remaining, it's a one-liner. It's really straightforward. So let's go ahead and go back and do just a very, very quick review for those who haven't watched the previous video. What is a node? In this case, they're calling it a list node. It's really just a structure where we can not necessarily structure, but it's a class. It's a kind of object where we can have some value inside of it. It doesn't have to be an integer. In this case, it's integer data. We can put like a string in there. We can put a double. We could put any kind of data we really want to store in there. We could put a JSON object, hypothetically, anything you kind of want to stick in there as your data. That's going to be your data. And then the next part is we're going to have a next pointer. And this is going to store a memory address to the next node in the sequence. So whenever you chain these together, you have the data 1, 2, 4, but you also have the memory address of the next node. And then you have this guy has the memory address of the next node. And that's how you're able to traverse the linked list. You have to do it sequentially because this first person doesn't know where the third person lives. So they actually have to go through the second person to get to the third person. Right, so that's something that's important. We have some constructors that are available. So notice if we use the default constructor, we get a value of 0, and we're pointing, our next pointer is pointing to null putter. Null putter is just it's not a valid memory address. It's in the sense that it's just 0. It's a way to kind of say that here's a memory address. It won't crash with it, but it'll just indicate to us that it's not pointing to anything. And so whenever you're pointing to null putter, that means you're either at the end of the list, or technically you're like a standalone, right? So, or you're at a standalone node. In this case, we have an overloaded constructor. We can provide some data inside of here, and we can go ahead and once again point to null putter. So it's a standalone node. And in this case, we actually provide 2 arguments. We can enter some data, and we can also put the memory address of an existing node. So that way you can actually chain together 2 nodes. So this is kind of nice because you can have a way to chain or create a list. But that's enough of our review with with nodes. You use these nodes together to combine them and to make a singly linked list. A singly linked list is exactly what we have here. You have a starting point, and each node is going to point to the next node in the sequence, and that's it. There's no way of going backwards. Well, there's, how should I say? There's any node does not have the address of its prior node. That's what it means by singly linked list. You're unidirectional. You're going forward, and then the last node is just pointing to null putter. There are some structures called doubly linked lists, in which case you can move forward and backwards because you have the address of the next guy and you also have the address of the previous guy. You have that. You also have like circularly linked lists. That's where you can kind of go in a circle in one direction, or you have, I think it's a doubly circular linked list where you can go in a circular pattern. You can imagine kind of like a necklace. You can go in a circular pattern forwards, or you can go backwards, and that's where it's doubly circle linked list, right? But enough about that. We only care about singly linked lists for today. And as a reminder, what was our previous pseudocode when we performed deep copies? When we perform deep copies, if you haven't done so already, strongly recommend watching that video, but let's go ahead and take a look at it. You would first have to always decide, well, which list are you going to choose, right? You always have to choose the smaller value, or in our case, if there's ever a tie, we're going to just choose list 1. So that's one decision. Then we would go ahead and create a deep copy of the node. So that's why we would have space complexity big O of n, because we were making copies of all our data. The next thing was we go ahead and join our existing list to the deep copy node. Go ahead and make that adjoinment. We would go ahead and move our current pointer forward on the existing list, so that if we wanted to go ahead and attach another node, we could always attach at the end. And then the last part is have the list. Oh yeah, so we want to indicate that we use that list. We want to acknowledge that we use that node within our list. So we would go ahead and go to that list and move it forward, and move that head pointer forward. So that was the prior approach. I just wanted to kind of have that available so that you can perform a direct comparison from the prior approach to this approach, which is more efficient. And that's that we're going to use this, we're going to perform this in place, right? We're going to go ahead and kind of cross them over, not necessarily cross them, but we're going to go ahead and join them in a way so that we link them into one, we merge them into one big list. So step one is going to be the same. So if we need to decide which list to use, so if both are in bounds, we need to decide, right? So if both are in bounds, then these steps apply. Okay, if both are inbound. If only one is inbound, only one step applies. And that's what I mean by this. This solution is going to feel very, very straightforward once we get to this part. So once again, if you have two lists, then we have to decide which one to use. Then the next step is we're going to have our existing list. We're going to join it to the list that we chose. So this is equivalent, this step 2 is equivalent to step 3 in this part where we're joining our lists. Okay, just wanted to make that notation. For this next part, we're going to go ahead and this is where we have a kind of a new step. We're going to move our list header forward. So it's not that it's a new step, but it's going to be out of order. So in our prior solution, we did move our list forward. This is where we acknowledge that we used up that node. And so we want to move our list header forward. And then the next part is going to be having our existing list point to the next node. So for reference, or for this part, what we want to do is we want to move our current pointer forward so that once again, kind of like how before we wanted to add to the end of our list, we want to be able to perform that here as well. And then last but not least, we want to go ahead and have, we want to disconnect our two lists that we just joined together. So in order to disconnect them, we're going to go to our current pointer and we're going to go ahead and have it point, instead of pointing to whatever list we chose, like list 1 or list 2, we're going to have it point to null putter. And that's how we break that connection. So that's how we disconnect them. Lastly, and we're going to go ahead and repeat these 4 steps every single time whenever we have both lists inbounds. So that's just something to remember. Whenever we have both lists inbounds, that's what we're going to perform. Now, what happens if you only have one list inbound? If only one list is inbound, the easiest thing to do is you just have to link your existing list to the remainder of the list. That's it. And that's because they're already chained together. So you just have to get your existing list, chain it to the remainder, and you're done. And then that's really it. You're just going to go ahead and return the list that you built, like the merge list, excluding the dummy node like before, and that's it. That's really all there is to it. So now let's go ahead and see the logic that comes with this solution. What we're going to do is we're going to still use a dummy node. So notice here we created a dummy node, and we have our current pointer pointing to the dummy node, and this is just so that we can perform attachment, or we can link our existing list to link our existing list to the new list. Now, the next thing we wanted, so that's the code that we have available so far, and that's what it looks like right here. Here's our dummy node. It's pointing to null, right? Our next pointer is pointing to null, and current is pointing to dummy. So pretty straightforward there. And this is an example test case that we're going to be using. Here are 2 lists. We have the list 1, or we have the list with the nodes 1, 2, 4. And then of course, the last node is always pointing to null. So that's list 1. And then we have the list 2 with the nodes 1, 3, 4, 5, 6. And then of course, since you're always at the end, 6, its next pointer is going to be pointing to null. Null putter, or 0, right? So you could kind of use them somewhat interchangeably. And here's the header. So I went ahead and decided to label them a little bit differently. So this is the header that's pointing to the first list. And then this is the header that's pointing to the second list. What we want to do is we want to have this solution. We want to be able to merge the 2 lists to create this part. And so what we're going to do is we're going to go through it step by step, and then we're going to go ahead and implement that code. So first off, what are those steps that we want to perform? That's going to be exactly these. So we need to decide from list 1 and list 2, which one are we going to use? Which one are we going to add first? Which node? Well, once again, if it's a smaller value, you're going to pick that one. But since it's a tie, we're just going to go ahead and choose to use the smaller value, or use list 1. That's just arbitrary. You can choose to use list 1, list 2. Really makes no difference. I just chose for my implementation to use list 1, but it makes no difference in the algorithm at this for that specific step. So what we're going to do is we're going to go ahead and copy this list just to show that it's the whole list that we're going to drag over. So we decided to pick this list. So step 1, done. Step 2, we're going to join these two lists together. So what I'm going to do is I'm going to have current instead of, or the existing list point to the list that we chose, which was list 1, denoted by H1. And so how do we join them? Well, the logic is really we just get the current pointer, whatever the current pointer is pointing to, which is dummy, we get its next pointer instead of pointing to null, we get it to point to the node at H1. Okay, right there, like that. So now we went ahead and joined them together. Just like that. Okay, looks good. Once that's done, we acknowledge that we used up this node. So we're going to go ahead and push our header node forward right here so that it's used up. And what we're going to do next, so that was step 2. Actually, step 2 was joining them. Step 3 was moving our header pointer forward. Step 4 now is going to be moving our current pointer forward. So let's go ahead and move it forward so that next time if I ever have to add, I'm always going to add to the end. And then the last step is we need to break these apart because you can see that they're joined together. So we want our whatever our current is pointing to, we want its next pointer to point to null. So what we're going to do is we're going to have this point to null and break this apart like that. And so you can see that what's left of H1 is just this. I'm going to go ahead and push H1 here just to show that they're really the same. I'll erase it from here and erase it from here. I'm not going to really erase this, but I'm just going to show that H1 is only pointing to this part of the list. And that's really the logic. We're just going to continue to repeat that. It only gets interesting from here on out. So we're going to repeat these steps until we're left with only one list. Once we get to one list, it's going to be, we're going to stop those 4 steps and we're just going to go ahead, or stop those 5 steps, I should say. And we're just going to perform a single step. So let's continue. So between the value 2 and 1, which one's smaller? 1 is. So we're going to use list H2 or list 2. We're going to go ahead and copy this over. We're going to go ahead and join them. How do I join them? Like that. And so this is where H2 is. We're going to acknowledge that it was used. We're going to push H2 forward. And then we're going to go ahead and push our current forward. And then now we have to disjoin them. So in order to disjoin them, I'm going to go ahead and stick null right here. Like that. And just like that, we used up this element. Okay, so I'm going to go ahead and delete it from here, and remember we pushed this forward here. So now we're down to now we're using these 2 for comparison. So which one's smaller? It's going to be this list, right? The value 2 is smaller. So we're going to go ahead and paste that in here. We're going to go ahead and join them together. Then afterwards, so this is going to be list 1. We're going to go ahead and move. We're going to acknowledge that we used up this 2. So move the header forward. So we're going to go ahead and move the header forward like that. We're going to push our current pointer forward, and then we're going to disjoin them. So we're going to stick a null right here, and just like that, they're no longer tied together. Just like that, it's just a little bit of spacing issue, but essentially they're no longer tied together, and that means that this was used already. Now we have a comparison between, oh, actually, which list did I use? I used this list right here. Okay, perfect. Now we have a comparison between 3 and 4. Let's go ahead and copy that over. Place that over here. And then this is going to be list H2, right? The H2 we're using. We're going to join them together like that. And there we are. And then we're going to acknowledge that we used it. So move our header forward, move our current pointer forward, and then we're going to go ahead and disjoin them. No, like that. And just like that, we're done with using that 3. Almost getting to that interesting part. We're at 4 and 4. Remember, when there's a tie, use list 1. Go ahead and put that here. And then we're going to go ahead and use, that's list 1. We're going to go ahead and stick them together again. As you can see, it's very repetitive in terms of the steps. We're going to move our H1 here just to indicate that it's here. Next up is we're going to acknowledge that this was used up. So now H1 is pointing to null. It's no longer really exists. You can think of it that way. It's pointing to nothing that exists. We're going to move our current pointer forward, and then it shouldn't it's no longer going to be pointing to, or we're going to go ahead and break that chain from each other, right? And so you could see that our list one is complete. There's only one list remaining. And now we're getting to the easy part. The easy part is when there's only one list inbound, all we need to do is we need to get the remaining list. In this case, it's list two. And we're going to go ahead and link it to the existing list. So we're going to go ahead and have our current list or our existing list point to the remainder of the list. And just like that, you could see that what we were working towards is exactly what our output should be. 1, 1, 2, 3, 4, 4, 5, 6. And the last value is going to be pointing to null. That's the solution for merging two sorted lists. Or that's actually the, how should I say, the pseudocode or the logic for sorting two lists. We're just performing those same steps. And with regards to coding it, it's going to feel very, very similar to our last problem. Let's go ahead and code it out together. The way we're going to code it out is we're going to consider when both lists exist. And this is where we're going to have several steps. So how do we know when both lists exist? Well, list one exists and list two exists, right? So you could say not equal to null footer as well, but it's just, I find it a little bit easier to say while they both exist like this, what are we going to do? We're going to go ahead and we're going to have to decide which list to use, list one or list two. And so for convenience, let's create some variables. Create some variables for the values. So the way we do that is we say int list one value is equal to list one, and then the arrow operator to its data. And then we're going to do the same for list two value. And I just found that this makes it a little bit more readable in our solution. It's not necessary, but it's just for convenience. The next step is going to be which list do we use? And to decide that, we're going to use an if statement. We're going to say if list one is less than or equal to. Remember, if there's a tiebreaker, we just go with list one. Then what we want to do is we want to choose list one. So choose list one. Choose list one. There we go. So what are the steps that we want to do? So we completed the first criteria, which is decide which list to choose. If we choose list one, it's in the if statement. If we choose list two, it's going to be in the else statement. So now let's go to the second step. We have our existing list point to the list that we selected, or so we go ahead and join them together. The way we do that is we're going to have our current next point to the list that we chose, which in this case was list one. And that's where we, once again, this is known as have our existing list point to the list we chose. Okay, looks good. Then what we want to do is we want to acknowledge that we use that node. And so in order to acknowledge it, we have to move our list header forward one time. So we're going to say is list one, which is the list we chose. We're going to go ahead and move that forward. So that's where we say we move the header for list one forward, right? Then afterwards, we said we wanted to move the current pointer forward, right? That's so that we can go ahead and add to the end for the next time. So the way we do this is we go ahead and say current is equal to current arrow next, and that's how we move the current forward, move our current pointer forward. Pointer forward, and then this is so we can always add to the end. Add to the end. Let's get some more real estate on here. So I'm just going to go ahead and move this forward. And the last part is we need to disjoin them. We need to disconnect the two lists. So the way we disconnect them is we go ahead and say current next is equal to null footer. And that's how we break apart the existing list from the remainder of list one. Okay. So that's essentially how we do it if we use list one. If we use list two, it's an identical copy from this. So for the sake, actually, let's go ahead and write it out. So we don't want to. So we know in this case we're choosing list two. List two. What we want to do is we want to join our existing list to the list that we chose. So join existing list to list we chose. The next thing we want to do is we want to acknowledge that we use that node. So we want to move our list one header forward. So we're going to say list 2 is equal to list 2 next. And this is how we move the header for list 2 forward. Next up is we want to go ahead and move our current pointer forward. This is the same regardless. Current pointer forward, so move our current pointer forward. Always add to the end. So this is so we make sure we always add to the end. And then the last part of this is we want to disjoin them, right? Because if we don't want to fully join them unless there's only one list available. So we're going to go ahead and disjoin them now that we've added the single node that we wanted. And so in order to do that, we just have it point to null footer. And this is how we break apart the existing list from the remainder of list 2. Okay, so this is what we do when, once again, we have 2 lists available. But what happens if you don't have 2 lists available? Then you only need to perform one action. So if we only have 1 list available, so there's only 1 remaining, let's consider list 1. So if list 1 is available, so only list 1 is within bounds, so list 2 is finished. What we're going to do is we want to go ahead and connect them. That's it. That's all we want to do. We want to connect our existing list to list 1. Right? We want to connect our existing list to list 1, like that. Now, what if the other list was available? So if list 2 was available, then once again, it's just a one-liner. We're going to go ahead and connect our existing list to list 2. So connect our existing list to list 2. Okay, and that's really it. By this point, we've built our list. We've merged the 2 linked lists to linked lists. And then all that's left to do is return the answer. So in order to return the answer, once again, we don't want to return it from the dummy node. We want to return it to what the dummy node is pointing to, one node after. So we want to return this. And the way to do that is we're going to go ahead and return whatever the dummy is pointing to, just like that. And so granted, if I didn't write any syntax errors, let's go ahead and check. This should be the correct solution. Let's see where I may have made a mistake. Let's see. So while list 1 and list 2. Okay, so here's our 2 values. What we want to do is we want to say our current list is pointing to list 1. List 1 moves forward. In this case, we're going to go ahead and shift our current pointer forward as well. We're going to go ahead and disconnect them. That looks good. So list 1, that should all be list 1s. This should all be list 2s. Yeah, that looks good. And yeah, that looks good. So let's go ahead and take a look back at the console. 1, 2, 3, 4. So our output was out of order. So it has to do with the comparisons that we were making. So let's take a look. If list 1 is less than or equal to list 2, here's our values. Oh, I see. I have to compare the values, not the pointers. But it doesn't make sense to compare the pointers. I need to compare the values. So there we go. Some live troubleshooting, I should say. So it looks like it passed all the test cases. We're going to go ahead and submit the answer, and it should be good. So I hope that made sense. That was the solution to merge 2 lists in place. Remember, constant space, and it's actually a little bit simpler than performing a deep copy. I really hope you enjoyed. Please feel free to like, comment, share, and subscribe if you did enjoy, and I hope to see you soon for more coding solutions. Thank you so much for watching.